Now we will discuss the power flow diagram. So this is going to be different for a generator and a motor. So what will happen for the generator? If you consider this to be the input power. The input power for the generator, what will it be? It will be mechanical power. So you can write here mechanical input is equal to the input power. Now out of this total available input power, some of it will be used off for mechanical losses. So this comprises of the friction and windage losses. So what will be the left out power? This will be the left out power. From here, once again the core losses will be, you can take off. Okay. Now what will be the remaining energy? This will be the remaining energy. Okay. So now this energy that is available after we take out the mechanical and the core losses, that is the energy that is converted from mechanical form to input form. So we will represent it as P converted. Okay. Now whatever energy is converted into the electrical form, the entire energy will not be available for the actual output. Okay. So what will be the losses that you encounter here? First will be the copper losses. You can write I square R losses for the shunt field as well as the armature winding. Okay. And from here this will be the remaining energy, let us say. From here once again you will be taking out the brush contact losses. Okay. After you remove all of this energy, then whatever amount is remaining, this is the output power, electrical output. Okay. So this is what we call as the power flow diagram. What is the input? What are all the losses in order? That means first the mechanical input, it will cater to the mechanical and core losses, and the remaining energy will then be converted into the electrical form. Now this electrical, whatever energy is converted into the electrical form, you take away the losses and then you get the output, the electrical output. Okay, so this is called as the power flow diagram. So you can write down the meaning of the few terms here. P converted is the energy converted from mechanical to electrical form, because that is what happens in a generator. Okay. So this is equal to the input power minus mechanical losses minus core losses. Okay. Then what is the actual output available? This is not equal to the converted. What will it be? P output is equal to, from the converted loss energy, you have to subtract the copper losses or the I square losses as well as the brush contact losses. Then you are going to get the actual output that is available. Okay. So this is the power flow diagram and the terms for a generator. Now what about motor? It is just going to be reverse. Okay. First, what is the energy that is available? Electrical power will be given as input. So this is equal to the input power. Now from this input power, what will be the first losses that have to be removed? The brush losses and the copper losses or the I square R losses. Same as for the shunt field as well as the armature winding, the armature copper losses will be used up. Okay. So now after this losses are taken care of, then whatever energy is left out, that will be converted into the mechanical form. So here this is the P converted. Okay. Now whatever is converted, the entire thing is not available. It will be used up first in the form of core losses and in the form of mechanical losses. Okay. So here whatever power is available, that is the final output power. And what will this output power be in the form of? It will be in the form of mechanical energy. Okay. So this is how you draw the power flow diagram. Often you draw an arrow here as well to show the direction of power flow. Okay. So this is for motor. Now here you can write down what each of these terms mean. P converted is the energy converted from electrical form to mechanical form. Okay, so this is the case for motor. What will it be equal to? It will be equal to the input power, which is in the electrical form, minus the brush contact losses minus I square R losses. Okay, then what is the actual output available? Actual available output is represented as P output, which is equal to, from the converted energy, you subtract once again the core losses and the mechanical losses. That means whatever energy is converted into mechanical form, some of it is used off in the form of core losses and mechanical losses, and then whatever is remaining is the actual available output. Okay.